Now we want to continue. Good afternoon, guys. Welcome to the next part of our series on limit of function. Now we are told to examine the limit as s tends to 2 or approaches 2 of what? X raised to power 3. Now we told you in the previous video, if you haven't checked it yet, oh my brother, my sister, you're not doing the best thing because you may not be able to understand the concept discussed here. Now, we told you in the previous video that this kind of limit is said to exist if the limit, left-hand limit, equals the right-hand limit. Left-hand limit, that is limit from the left. Let's say limits, we want to examine limits from the left as s is going to 2 of x cubed, but from the left. Now, how do I know that in the first place? Think of number line, number graph. Think of this number graph. And then here, let me make, our reference point is what? 2 is our reference point. Now, this is 2. Now, please, what you are doing must be in the neighborhood of 2 to test for limit. Because I want to test for limit as s is approaching 2 now. Doesn't mean I will go and start from 3, 4, 5. No, it will be in the neighborhood. In fact, preferably 0.1 distance should be your starting point. 0.1 distance from 2, both to the left and to the right. So if I'm saying you are using 0.1 distance for algebraic stuff, if you are testing this kind of thing, maybe limit as x squared plus 4x, and then maybe at x equal to 1, just go 0.1 distance. Okay, as s equal to 0, 0.1 distance to the left and to the right. So if I'm going 0.1 distance to the left, meaning I'm starting from somewhere like what? 1.9. 0.1 distance to the left, that will be what? 2 minus 0.1, and that is 1.9. So my starting point will be 1.9, and then the next thing is what? I'll go 1.99, and then you go 1.999. Somebody is saying, why is it like that? It's because we want to create a rhythm. Okay, 0.1 distance. Okay, we want to try 0.01 distance. We want to try 0.001 distance. We want to try 0.0001 distance. And that's how you continue doing the limit like that. So do you understand now? So this number is not up to 2. That's why we say the left. If you check the number line, this is the right of the number line. This is the left of the number line. So we're saying you are testing limits from the left. It means numbers that are not up to. But don't forget, your starting point should be max. Bro, start with 0.1 distance. And then you can go 0.01, and then 0.001, and then you continue like that. So how would that be? So meaning that I want to test the limit of this function from the left now. I already know my starting point. Of course, the input is x, the output is f of x. So I will try for 1.9, my starting point. And of course, the function is what? X cubed. Don't forget, the function is cubed. And of course, I believe you know how to do this kind of thing. If I give you f of x, let's play. If f of x equals 4 plus x, then f of 1 will be what? Anywhere you see x, you put 1. So this will be 4 plus 1, that is 5. What will f of 2 be? F of 2 be what? 4 plus 2, that is 6. What will f of 3 be? F of 3 be what? 4 plus 3, that is 7. That's how we do it. Just impute the value. Now for this one, our f of x is what? X cubed. It means each of these things, I will cube it. So if you cube 1.9, you should get 6.859. Okay? That's still not a good judgment. Let's continue. How about 1.99 going 0.01 distance? If you keep 1.99, you should get 7.880599. Still not good. Let's take it through like a lot of series of tests. How about to cube 1.999? You should get 7.98800599. That's still close. How about 1.9999? If you do that, you should get 7.99. You can do all this with your calculator, so you shouldn't worry. 7.9988, and then you have 1, 2, 3 zeros, and then a 5, 1, 2, 3, 4. Nice. Okay, how about to do 1.99999? 5 nines. This should be, you should get 7.123999, then 8, and then 4 zeros, and then a 5, and then 5 nines. You can keep repeating it. Now, but one thing we notice, as we are getting closer, my brother, you can bear me witness that 1.999 now, 1.999 will be here, and then 1.49 should be here, and then 1.59 should be here. As it is getting closer and closer and closer to 2, what is happening to our output? What is it getting closer to? It is getting closer to 8. So we can conclude our limit as s approaches 2 from the left of what x cube is actually 8. Note, in fact, I don't just want to do that so that I don't want to paint an image in your head. Even as I should have said, you can just push it up and then you do 1 point, a lot of nice, plenty nice, like 13 nines, 14 nines, then cube it. The calculator will give you 8. Not because 8 is the value, but because calculator is tired of approximation. In fact, this value, I know your calculator cannot bring it out. It will only approximate it. So because calculator is tired, it will give you something like 7.99999. So the calculator will just like, instead of me repeating the nines, why do I not give you 8? Do you get what I'm saying? So that is that. How about the limit from the right? We've tested the limit from the left. What do we get? We get 8. Now, from the right, we said, don't forget, we went 0.1 distance to the left. 0.1 distance to the left. So we are going 0.1 distance to the right. That will be 2 plus 0.1. And that is what? 2.1. So our starting point is going to be 2.1. But somebody is saying, if I want to continue, what would that be? You are coming to the left. So you're not going 2.11. 2.11 means you are going to further. But we said access is approaching 2. So approaching 2, your next one will be what? 2.01. The next one will be what? 2.001. And then you keep approaching and approaching and approaching 2. Now, how will that look like? Let's now continue. Still the same function. Still the same function. Sorry. Still the same function. Don't mind my lines. Now, the function is still what? Our input x. Our output is f of x, which is what? X cubed. Our starting point is 2.1. Now we cube 2.1. 2.1 raised per 3, you should get 9.261. Well, that's a good starting point. Not bad. How about 2.01 raised to power 3? You should get 8.120601. How about 2.001? Well, you should get an output of 8.01200601. I think it's giving us a pattern already. And then how about 2.0001? You should get 8.0012000060001. How about 2.00001? You should know what that is already. Learn to study pattern in mathematics. I think the pattern, even without a calculator, should be 8 points. This is 2 0 years, so that will be 3 zeros. And then 1 2. This is 3 0 years, and that will be what? 4 zeros. And then 6 3 0, and then that will be 4 zeros 1. Now we don't want to keep punching and punching. I think I did one. How many years? I think we did 1 2 3 4 5, and I think here is already 1 2 3 4 5. Now someone here can conclude that this thing is approaching what? 2, 8. The closer we are getting to 2, the more the function is approaching 8. So I can then conclude that the limit as s goes to 2 again from the right of x cubed is 8. Now, here we got an 8. Here too, let's come back, we get an 8. That is the limit from the left, and the limit from the right is 8. Then we can now conclude that the limit as s approaches 2 of x cubed is actually 8. That's how to play the game around limit. Very simple. If you are told to examine limit, this is an algebra that we have secondary school students. A lot of secondary school students, when they open new project for their mathematics and they run that thing there, some of them don't really understand how they come about with that. And even university students too. At least the idea of me understanding how to examine limits or algebraic limits makes life easy for me. Again, I said, go 0.1 distance to the left and right if it's algebra. And then continue with 0.01 distance to left and right, 0.001 distance left and right, and then you continue. So what's your function? The output is now approaching is what will determine if the limit really exists at that point. I believe this is clear. Thank you.